for the introduction. It's really great to be here, and I'm looking forward to talking through, to giving you a virtual tour of the project that you can see here, which is a project in Muswell Hill. I'll just move to telling you a little bit about me, if I can get the slides working. Ooh, how do I move the slides forward? Ah, there we go. Okay, so I have a specialism in low carbon retrofitting using natural materials, and this is what you have on the screen here is in principle my vision to try and not only lower energy but improve my clients' quality of life and well-being, give greatly improved indoor air quality, and have a positive environmental impact. And you'll see why that's important as we go through the slides today. So as many of you are probably aware and probably experiencing, our old housing stock is incredibly leaky, leaving us feeling very cold inside our homes in the winter. I was really shocked when I visited a friend's house last year who had the temperature at 12 degrees. It was a really icy day, but I couldn't believe that you know, in where we are in our century, that that they would have to experience that level of cold. And as everyone knows, that the energy prices have been skyrocketing, although calmed down a bit more recently. If you're not aware, these are some of the emissions, sort of global building sector emissions. So the operation of our building, our buildings accounts for 28%, and that's basically the power that goes into our buildings. And the construction of them accounts for 11%. So both these feed into what I try to do in trying to reduce the energy consumption of the building in its use and also in the way that we build it. And a little bit about retrofitting. Our homes use 35% of all the energy used in the UK and emit 20% of the carbon dioxide emissions. So they have a significant impact on energy in the UK. So I'm going to talk about this project. It's in Muswell Hill. It was, I'd say, a dream project for me. I had a very willing client who had been an entrepreneur and had an aptitude for risk. He was very excited by the ideas I put forward to be able to use natural materials. He was completely on board in trying to go low carbon. So it was just a great experience. It was always fabulous to ring him up and come up with a new idea and to have a sort of excited, positive response. He would get as excited as I was about it, so it was great. And this is where we started. We started with the worst possible energy efficiency rating that it could have got, with a score of 1, and a very high cost for heating the property. And bear in mind, this EPC was done in early 2020. So it would be a lot higher than that now if it was in the same condition at this point. So just to touch on, sorry, I'll go back there. So we started with the heat demand of 650 kilowatt hours per meter square per year. And we took that down to the figure on the left, which is a sort of estimated 32 kilowatt hours per meter square per year. I say estimated because our passive house planning package gave us a result of 35 if we hit an air tightness of 2 and 30 if we hit an air tightness of 1, and we reached 1.34, and that was as we were doing the first test, and we did more work on it afterwards. So we've estimated it as at around 32. So for those who are not familiar with this kind of language, a regular leaky house is about 300. A modern house reaches about 150, and a passive house, which is the ultimate in energy efficiency, can reach about 15 kilowatt hours per meter square per year. That's the threshold. It has to be 15 or below for passive house. We were trying to reach Enfit, but for that we needed to be at 25. We didn't quite get there, but having reduced it by 95%, we're pretty satisfied that we did a pretty good job in making such a huge reduction. So that's the 95% energy efficiency improvement. Now, we worked on the principle that trees are made from air, and that anything that was grown was extracting carbon from the atmosphere, and therefore, if we put it in the building, it would have a positive environmental impact rather than a negative one. And so we looked at, there's a nice little video on this from a Canadian company that is doing similar things to what we're doing in the UK. And they look at conventional materials versus carbon storing ones, the ones that are grown. And they have this graph which shows the CO2 emitted over the life cycle. And you get the similar CO2 being emitted through some of the manufacturing processes and construction, but with a grown material starting below the sort of zero line, because it's stored carbon during its growth, and therefore the impact is positive rather than negative. And they also have this nice infographic. This is this Canadian company, which shows that you can build the same building in 4 different ways. And the more you go towards something built out of mud and straw, the further you get over to the right-hand side. And some of the most innovative construction that is going on around the world and in the UK is going as far as using mud and straw, which some of you might be working on yourselves or are aware of. I would say in this project, we probably got to the yellow one rather than all the way to the green. However, we haven't done our own assessment. We've just worked with the principle that if it was something that was growing, it was going to have a positive effect. So here's my client feeling very proud about all the wood fibre he was putting into his building, and there it is all stacked up around him. And we filmed the project, so he's doing a little chat about what we were doing here and the wood fibre and its effect. So just to give you a little preview of the design, we tackled this building in there were a lot of extensions. So we had a ground floor extension, we had a basement extension, and we had 2 rooftop extensions. So we had a dormer at the back and a dormer at the front that was rebuilt. We also, because the back wall was in such terrible disrepair and we were removing the central chimney, we decided that there was so little of it left that we might as well rebuild it and increase the U value across that back wall, because at the time we were attempting to get to Enbee levels. So I'm going to take you through the build-ups and give you a bit of a tour around the building as we do so. On the existing walls, we had a build-up which was basically a parge coat to level out the walls, followed by diathanite. We had 25 mil of diathanite, which was it's a lime and cork mix that got sprayed on, and then we put 80 mil of wood fibre on top, and then that had lime plaster on top of that. And we did that on all the external walls, and you can see some of it here. On the right-hand side, you can see the diathanite, which has been smoothed out. Then you can start to see on the left-hand side at the top of the wood fibre there, you can see the bonding coat, and we bonded the wood fibre on with that, and then it gets pinned onto the wall as well. And on the left-hand side, you can see the diathanite before it's been smoothed out. And there it is, looking very smooth in how that hallway looks now. And the entrance door. And just adjacent to the entrance hall, the kitchen living area, with all those walls having that application of the 25 mil of diathanite and 80 mil of wood fibre on top. Just going to check the time. Okay. And then on the back wall, where we rebuilt it, this was the construction. We had a timber frame, which was filled with flexible insulation and solid board of wood fibre on top. And then we salvaged all the bricks from the demolition and hung them back in a single skin, which was ventilated. And just to give you an idea, in the reduction of the U value here, we started with the original U value, which would be about around 2. You can see it in the bottom right hand corner, and we reached 0.15. And the previous one we reached 0.3 and 0.32 depending on thickness. So that was the existing walls, the existing solid walls got to 0.3 or 0.32. And here you can see the rear wall before it was filled with the flexible wood fibre insulation. And here you can see that process happening where you have the flexible wood fibre and then the solid board put on top. And one of the things that's very difficult in retrofit, and the sort of complication of junctions and insulating the structure, is the structure passing through a insulated zone and then sitting in the external wall, which is then cold. So we always had to look at how to manage any steel beams passing through our insulated zone. Here you can see that back wall and all the bricks that we salvaged, or some of the bricks that we salvaged, waiting to be put back on the rear elevation. And there it is again. And how it looks now, just to see the end result. Now I'm taking you up to the roofs. This is, you can see into one of the dormer openings. It has the same construction to the back wall, basically a solid, full-filled, flexible, full-filled rafters with a solid board on top, and then it's all lined with OSB, which was taped with this blue tape. It's air tightness tape, and all the screw holes were taped as well, because if you want to get it really airtight, this is the level of attention that is required. And you can see one of the spaces before we retrofitted, when we'd stripped back to the brickwork and the stud work. At this point, did feel like we'd taken quite a lot of the building apart. And you can see the back wall there, and the rear roof, which was rebuilt in its entirety. We managed to keep one part of the roof in place, which is on the left-hand side there. And this is the build-up of the dormers, and this is me just calculating how much OSB we used to start to think about how much wood we were putting into the building. I love this shot of my client standing on a pile of wood fibre, looking out of the big windows at the top of the house for the first time. He was so excited and couldn't stop shouting "wow," which was very satisfying, having been working on the project for about 2 years by this point. It was very exciting to see his reaction. And that's that same opening in its sort of finished form, and we used we had to use vapor open paints, and all the walls were plastered with lime plaster. And the same for this bedroom next door, with the dormer there being another new dormer which we made bigger. That's that same bedroom again. And now we're dropping down to the ground floor extension. Here we opted to use, they were called Duo, or we originally specified Porotherm bricks, but it was easier to get the Duo ones into the UK. We had to import them from Europe, which did add significantly to the cost of the material. At the time, they weren't available in the UK. I don't know if that has changed since. And we opted for a solid masonry construction because we would have loved to have built it with the timber frame, wood fibre timber frame, as we did with the back wall. However, it went right up to the boundary, and if the neighbour was to build up to it, that could have caused problems with the ventilation of the wall. So we opted for this as our construction method. And the hollow bricks provided a lot of insulation in themselves. And then all we had to do was put another, I think it was 25 millimeters of diathanite, and then plaster it. And the slab we insulated using Glaypor, which we then had a limecrete slab over the top. And these were the methods we were using at the time to try and get it as low carbon as possible. I'm currently doing one where we're having a suspended timber floor because through our calculations that's even lower, but in this instance we used a solid slab floor. And there you can see it in construction. We had cantilevered areas. We managed to not have very much steel in it, and that was because we had a very enthusiastic structural engineer, Toby McLean, if any of you know him, because he was just as enthused by going low carbon. We had lots of strategy conversations about how could we bring the carbon impact down, and it was really great to be able to work with him. So this is a view as you walk from the kitchen into the extension, which is called the Snug, and a view from the inside of it. Very boldly painted in red by our client. We were always a little bit afraid of how it might turn out, but in fact, I think it's a very dramatic and bold move, and I think it's worked well. And a little view of it from the outside. Here we used brick slips against the Porotherm bricks, and you can see it's joining the rear wall of the building, and you can see some ventilation bricks there which are helping to vent the 50 mil void. And we also used external blinds on the extension, and that is because you reduce the heat gain by significantly more. It's 70% more effective if you have the blinds on the outside, as they have all across Europe in hot countries. And as the temperatures are raising here, we too are becoming a fairly hot country in the summer. Now I'm going to move on to the basement. I'm just going to take a sip of tea because my mouth is drying out, so excuse me for a second. The basement was the most difficult thing to get to be low carbon, and we achieved it in some ways and we didn't in others. I could do the whole talk just on the basement, so I'll have to give you a brief summary of what we did. You can see here on the right, I don't know if you can see my cursor, but on the right there are some polystyrene boards which were used on the outside of the existing walls. We had to dig a trench around the outside and put them where we were underpinning, because it formed the first layer of the underpin. And I used this specification from the structural engineer to play into our build-ups for the basement and to help reduce the U values. So with that in mind, we had the EPS formwork, which was 70 millimeters. And then we spoke with lots of concrete experts to reduce the carbon impact of the actual concrete we were using and to make it an insulating concrete. And in fact, we had tarmac and London concrete come up with a specialist mix, which was brilliant in theory. We were able to then only put another 100 mil of cork insulation on the inside, so it really helped with giving us more space internally and reaching the 0.15 U value that we were attempting to reach. However, in practice, we were not allowed to, we were only, what was it? We were, the delivery was a minimum 2 cubic meters of concrete at a time, and we couldn't always pour that amount, which meant that some of it was wasted. We did as much as we could. We put it into the under the as part of, we sort of substitute some of the block work in the underground part of the extension, and so we did what we could with it, but we did have some wastage, And that is because, in my view, the concrete industry isn't ready to have low carbon concrete in a domestic scenario. And that's because not enough people are using it. And if it had been regular concrete, they could have gone to our site and then onto another site and another site. And therefore, there wouldn't have been a minimum value that they would have to give to us. And there you see the slab. We have a again, the insulating slab. We did have to use some XPS here. We managed to minimize it to 80 mil thick. And then we did the rest of the insulation, which was 100 mil of cork insulation. And this was me working out our build-ups to try and get to the 0.15 U value, and I used Ubicus as a helpful assistant to work these things out, and it would tell me if there was moisture appearing in the build-up. And when the moisture drops look too big, I would get in touch with the client and said, this is the only option we have. However, I think we should run a woofy calc to see how it's going to perform over 10 years, because the Ubicus calculator, although really helpful, is just giving you a single snapshot of one day when it's, say, 0 degrees outside and 21 degrees inside. Whereas the woofy calc gives a much broader picture of how the build-up is going to perform over 10 years. And in fact, we found that all the build-ups we tested would be okay over 10 years with some very minor interventions. I'll just move on to the windows and have another quick check on the time. Just a second. Okay. So on the windows, putting the windows in, it has a very it's done in a very specific way. It's really important that they're set within an insulated zone. So you can see on the left there's the white compact foam, which is where we fix our windows. And then when we put them in the middle shot, you can see we've got some I can't think what it's called now. Isoblocco, that's right. Some Isoblocco, which is an expanding air tightness foam, which expands and contracts a bit like the sort of mats that you might sleep on when camping. It's basically a memory foam. And if the building then has some adjustments after its build, which they very often do, this memory foam is going to adjust, and you therefore not get air leakage. Whereas the spray foams, which go hard when the building moves, it might be airtight at the beginning, but when the building moves, you can end up with gaps and therefore some air leakage around the windows. And then on the right hand side, you can see our inner layer of wood wool, which carried our lime plaster, and the blue tape adding to the air tightness. So we've got several points where we're ensuring the air tightness, the connection between the window and the construction, and then we taped onto the window from the inside. And the windows themselves are incredibly airtight as well, reaching a category 4, which I think is here, air tightness class 4. So you can see there me in one of the tours demonstrating the window and showing that there were several seals which really help with the air tightness, and when you shut the window it sort of cranks shut. And then we also replicated the existing door and remade it as a also a sort of passive house door with the air tightness class of 4. And there you can see at the back we had contemporary windows as well. Sorry, just going to let my client tell you a bit about the windows for 2 minutes.
You know, you were talking about materials, is the windows as well. So, you know, it's normal, you know, we're all familiar with the experience of you come up to a window and you just feel that cold that you're describing. You know, you come up to a window and you just feel a bit of a chill, and it's kind of uncanny the way in this house the windows are. I mean, windows actually need a mention as well as the diathanite wood fibre. The windows are amazing. Today there was some roadworks going on, like here there's a outside, and I just closed the window. It was unbelievable how sound just went dead almost instantly. I mean, they are astonishing from a noise reduction point of view. And here we've got a great big glass door, a great big glass window out onto the patio. And, you know, it can be snowing outside because we've had that this year. And you stand in front of it and you don't get that cold feeling. Yeah. That's extraordinary. That's what we're trying to do. Yeah. Just like we managed to. Yeah, definitely. That's good.
Oh, sorry. Next one. Okay, and just to touch on the renewables, we put in an air source heat pump, an MVHR, we had solar panels, we have underfloor heating, and we did put in a little bit of air conditioning for the top floor. And the snug, and in fact the snug, it's never needed to be used, so that we wouldn't do that again. However, it very occasionally gets used on the top floor on the really hot days.
And Natalie, it's coming up to 22 now. We've got a few questions, so good.
Okay,
address
I'll
that.
give 5 more minutes, whiz through the last lot. Thank you very much.
Right.
Okay, so the kitchen, just a few things on the interior. It has the meshed lime plaster, low VOC paints, stone worktop, a sustainable kitchen supplier, and a tiled and timber floor with underfloor heating. And a little picture of the kitchen there. Always like to get into the photos if I can. And then bathroom, one of the cloakroom, where we reused some of the timber floors that we'd taken up, and we used it as the paneling in the bathroom to give a nice sort of shabby chic look. The staircase, which was one of the original features that we managed to keep, and we stripped it right back and repainted it, and it's in our hallway, which you can see here. The white is the lime plaster, and then the other walls were done in the gypsum plaster. And then we've got the hallway where we had oak flooring and low VOC paints, and that's our original image of the hall. And oops, sorry, how it looks now, and another view of it. And then we found that generally retrofit is of interest. In September, we had an open house, and I talked for 4 hours non-stop, or maybe it was 5 hours, and it just felt like it was constantly full, and that was very exciting to have so many people. And the client was really excited by the day, and really proud of what he'd done. And so we estimated that we had more than 200 visitors in that time. And very nicely, I've had some of my fellow architects come and visit the project, and I was sent this message. I think it was that cold snap in early December last year, and they was just so impressed by how warm the house was when it was so cold outside, and the heating wasn't even on. And so for us, the performance is as important as how the building looks. It's what we try and combine. And just to promote myself for a sec here, we've got a new retrofit strategy product that we launched at the end of last year, which helps with the initial assessment. And these are some of my collaborators on the project, which I'd like to sort of mention. Johanna did the interior architecture. She actually brought me into the project because it was originally her project, but she didn't have the retrofit experience, so I got brought in for that specialism. And the others are some of the other really experienced members of the team that helped put the information together. And this is the entire sort of key team members that we had involved in the project. And that's it. Thank you very much.
Thank you. Thank you very much, Natalie. Very, very informative, very enjoyable to hear. Yeah, the homeowner seems to be a very happy and fortunate guy. Yeah, we've got a lot of questions. I'll work backwards. Alex asked, do you have any bathrooms on external walls? What approach did you take to insulation in areas of very high humidity to buffer moisture?
We used cork in some areas. So cork is good in bathrooms because it's quite hard to use wood fiber in bathrooms. And we also have a lot of ventilation. We've got the MVHR extracting moisture all the time. It's on constantly. So we had those two strategies. In the basement, we were advised when we did the woofy calc to add a layer of passive purple, which is this intelligent membrane that was painted onto the lime to stop the moisture passing into the cork. So those were the strategies we used to address that type of thing.
Thank you. And then Chris has asked a follow-up question, actually. And how do you deal with tiling bathroom walls? Assuming tiling prevents external walls from breathing in a negative way, or would that be addressed by the MVHR?
So with tiling, we have we work with our suppliers and get their advice on that. I currently in this one we attempted not to put the tiles on the external walls in certain places. For example, the showers were not put up against the external walls, they were on an internal wall. Where that's unavoidable in one of my other projects, I'm just thinking about it. I've actually managed to get most of it away from the external wall, but however, we do have some cork insulation which can be tiled. So I would just advise speaking to the suppliers. They're really, really technically advanced and savvy. They need to give you all the advice that's going to allow their product to work. And that's basically what we do. We take our build-ups to our suppliers and get them to check them.
Okay, cool, thanks. A couple of people have asked, actually, including Jim, would it be possible just to scroll back to the previous slide where you talk about your partners, because I think people are hoping to learn who your structural engineer is, and also from a contractor, just a broader question. I'm assuming there aren't too many contractors around in London or wherever, like Emmanuel, that can can do this type of work. I mean, that's you know, if more and more architects advocate what you've been proposing, and the guys on the call as well. I mean, when it comes to using natural materials for retrofits, I mean, I suppose there's a limitation on the contractor base.
There's definitely a limitation. I have been there seem to be more in North London than South London, where the remainder of my projects are, because I'm based in South London. Although actually I've got another one in North London at the moment. However, I do feel that there is growing interest. And I did manage to find more than I anticipated. I think I've been talking to about 6 for some of my South London projects.
Cool.
But they are few and far between. It's not easy to find them, and you know, the price point is usually higher. You do need to have really if a contractor hasn't done it before, I would recommend that they are used to working in the high-end work, because the amount of detailing, and to get it right, and to get the air tightness right, and to not have the gaps in the insulation, it needs to have that level of attention to detail to be able to make it work. And when I've brought in contractors who were fairly small scale and had not had this experience before, they tended to underestimate how much work it was.
Yeah, no, I can understand that. I mean, clearly, in going forward, we have a couple of webinars on addressing retrofit at scale, and obviously this method isn't going to address retrofitting at scale. But your previous answers just sort of come on to Jim's question, because obviously the client was reasonably wealthy by the looks of it. So Jim's asking what the budget is, and you know, the cost on a meter squared basis, just out of interest to do something like this. I mean, you said yourself, there was nothing left of the house really inside. I mean, it was
yeah, I'd have to answer that one privately, because the client isn't willing for me to put that out there on something that's going to be on YouTube. I can answer it more broadly, that sort of I've seen a lot of articles written by some of my fellow architects, where they're saying you need a budget of £3,000 to 4,500 for projects that don't involve retrofit. I think if you're going to involve retrofit, it's probably higher, although where my clients don't have such a large budget, we're looking more at the 3,000 mark. And that, you know, when we were doing this, because we started it in 2020, 3,000 was considered to be a luxury high-end construction figure, but prices have increased so much since then. So yeah, I think if you don't put so much money into the you know, the tiling and the kitchen fit out and all the interior stuff, you can probably reach the lower one, but I would definitely advise bringing a QS in as early as possible, which is what I'm doing with all my future projects, because prices are so hard to manage, I think, with what's happened over the last few years.
Yeah, okay. Hopefully this will be a quicker question. I'm not sure whether it would be Next Step Heating, but who did your woofy calcs?
So that was Coda.
Oh, it was Coda, right?
It was Costas who did it, and they were originally Inhabit. Casper, Costas, and Tim were all at Inhabit, but then Inhabit got sold mid-project. So then we moved on to their new companies. Casper didn't want to go into the commercial sector, so he didn't go to CODA with everyone else. Costas and Dr. Sarah Price and Tim, I think, were all involved in a white paper that was written for BASE. So they were really leading people to be to understand the moisture calculations and implications. We had some of the best people in the country working on this, so we were lucky.
Spoken on a webinar previously. Alex has asked another question. Why did you use vented cavity behind insulation on rear elevation? Was this due to moisture risk? Did you? Oh yeah, so you did. Yeah, sorry. And then obviously we part answered the question. He then goes on to talk about woofy.
Yeah, so that ventilated, I as much as I can work with established systems, and that is it's a BBA registered system where you have the timber structure and you ventilate it, and you need to ventilate it to keep the I guess to keep the wood fiber from rotting, I assume.
So I'm just going through these. George has asked, can I ask why the combination of 20 mil diathanite and wood fiber as opposed to just an additional 20 mil to the wood fiber? Is that again moisture control?
No, it wasn't moisture control, and you can do it without. And for people who have a lower budget, that's what we do, and I recommend doing. For the greatest impact in terms of money spent to energy reduced, it runs between 40 and 60 millimeters. So you say you put 50 mil on, you get your greatest effect because you get diminishing returns after that. Although it sort of makes sense why people go a bit higher and go to 80 mil, because the labor cost is the same and it's only another 20 mil of wood fiber. It doesn't feel like a massive jump. Adding diathanite in, I would say, does add. It was to get our U values as low as possible. I think we would have got to about a 0.4 on the existing walls if we hadn't had the diathanite, but instead we got to 0.3 or 0.32 where it was 2 bricks thick, and 0.3 where it was 3 bricks thick.
Okay, cool. And is it fair to say, I mean, you work with a lot of natural materials, and you mentioned on projects with lower budgets, is wood fiber sort of the one material that you would propose? Really?
Yeah, I still propose it because it has such a positive impact on the building itself and the interior, the effect on the interior. I just recommend having it, taking it down to 50 mil instead of having it up at 80. Using vapor closed materials on old breathable walls, in my view, isn't ideal, and it also doesn't have the positive carbon impact that using wood fiber does.
Okay. I think we've answered the question from Lisa in terms of trying to find a contractor. Alex's first question, he talks, and actually I don't know enough to answer, but I thought this might come up. So Alex has asked, do you follow RICS guidelines for carbon calculation where you must account for carbon from grown elements at end of life, e.g. no such thing as carbon?
Okay. So I haven't got to that point yet. We just worked with first principles in the view that if it was grown, it was likely to be good. As my business grows, that is something that I do want to incorporate, where we do actual carbon calculations. We did it in, we just did it from, like, for example, Toby did a lot on the structure. He has some Excel spreadsheets that help him to work it all out. From my end, the Ubicus calculator gave a sort of snapshot on whether it was environmentally good or not. And however, that is something I would like to adopt in the future.
I'm sure that's something Mesh Energy could help you with the next
Yes,
time.
in fact, that's how I found you, was trying to work it out for this project. So
yeah, that's cool. I mean, I mean, for anyone else on the call, we do have a carbon calculator, free tool that people can use. It's really only suitable for the most basic of projects. Something like this, it probably wouldn't work for, but yeah, with the team set up to help anyone with those carbon calcs. So that's just a little plug for us. Don't often use these sessions to plug Mesh. Perhaps I should do a bit more. But no, honestly, that's been fantastic. It's now 1 o'clock. I'm not sure whether Richard at Mesh benefits. Richard said module D is a benefit external after the life of the building, so benefits a subsequent project. So a lot of letters there. I don't understand a word of that, Richard, but did you want to come off? Did you want to, what was that point in relation to, Richard, if you wanted to come off?
Yeah, I think there was a question regarding sequestered carbon.
Oh, right, yeah.
D, and basically, so there's a couple of things about sequestered carbon. Firstly, if you're using grown materials in a project, then the carbon has already been sequestered, so that's why we can't discount that from the life of the project. And conversely, module D releases carbon post demolition or deconstruction, and therefore, depending on how you retask those materials or what you use them for, then that released carbon gets passed on to any subsequent use. It doesn't really benefit the project itself.
I should have, that's a slap on my wrist, because obviously that's what you told us last week, and I apologise for not taking it all in. Said
it's one of those, sequestered carbon is one of those things that's always been a bit of a grey area up until recently. I think finally it's quite clear now about how to treat it.
I think what it is, though, is that in some instances those materials might go back into circulation and might get burnt or rot, and if it's put into the building, then that carbon is locked into the building for the lifetime of the building. It's not going to be going back into the air at that point. So that was the point that I was working with, was that by using materials that might otherwise, for example, the wood fiber is waste wood it's made out of. So it seems to me that that's a great place to put it.
Well, as you said, going back to first principles, even on that basis, it's the right thing to do. Sam Cooper's just asking this question again. I'm sorry, Sam, I missed it off. This will be the last question, because I know we all have to get on with our days. But he says, Natalie, did you cut back the joists that were bedded in the external walls?
We didn't, but we did have a special treatment for them. They had to be wrapped to. We had a special air tightness wrap around them, which was then sealed to the wall. We put the diath. We then sprayed the diathanite around them, and then we had in the floor zones we had wood fiber there, which helps to extract, sort of wick any moisture away from the if there's any condensation at the point where it meets the wall. The wood fiber in the floor zone helps to draw that away. And so that it's a method that's advocated by the industry.
Cool, marvelous. Thank you. Thanks for asking that question, Sam. Sorry, I was just reading the last comment from Alex. Alex is a regular attendee, and he's just saying how really interesting it was. And Alex is a passive house consultant that works on lots of, and he's doing a number of retrofit projects using natural materials. So it's always He always asks lots of tough questions as well, keeps people on their toes. So that's cool. Thank you very much. Kevin's asked, is there time to cover my question? I haven't seen a question, Kevin. I've just seen you. Oh, so I can see it now. Sorry. What absolutely last question. How close to these levels of insulation do you think it's quite a broad. How close to these levels of insulation do you think it's practically possible to achieve at volume for the UK housing stock? I mean, that might be a bit tough for you to answer that, wouldn't it, Natalie?
Well, I would be recommending the 50 mil as the sweet spot. For that, yeah, that would be my recommendation, to go to the point where it's you get the maximum impact for your spend. That would be what I would recommend.
Cool.
And I did that in a project that was being built at the same time. We were doing a loft. It was a loft, and we did the floor below. And with that one, it's really nice to hear the results from my client, who talked about, they hardly needed to put their heating on. They couldn't believe the impact. They couldn't believe how much of a difference it made to them. And we only did, they had an outrigger which has their kitchen and another bedroom and a bathroom. And that part wasn't tackled. We tackled the sort of main body of the house.
Mm-hmm.
And they just couldn't believe the difference when they walked from one side to the other, how much of a difference it made. And I have that in my own house. We've got the room I work in, the room I'm sitting in now.
Mm-hmm.
It's the only uninsulated room.
Okay.
With two external walls. So and that was because we ran out funds, and we were planning to do it externally in that location. And kind of felt, well, we can come back to something that's external. Something that, this everything that's internal has to go in, but if it's external, we can do that in the future.
Yeah, well, it keeps you honest and real as well. You realize the difference that you've made as well. So you've got something that you can experience every day. Show how well you've done in the rest of the house. So Natalie, thank you very much. Obviously your details are on here. I'll share them on the recording as well, so people can find you. If you don't mind sharing the deck with me, I can upload it to the recording tomorrow. It's great to have so many people on the call, so many questions. Thanks for everyone's time. Thank you, Natalie, once again. It's been really, really good to have you on the call and hear sort of the good work you've been doing. So no, much appreciated it. So enjoy the rest of the day, everyone. And I'll see you on future Meshwork webinars. Thanks a lot.
Great. Thank you. Thanks very much.
Guys, thanks, Natalie.